Well, welcome everybody to the presentation at 220, the real need for real-time data. My name is Dave McPhail. I'm the president and CEO of MMX. This is not going to be a product pitch. This is going to be more of a thought leadership piece. We have a booth at 1266. So if anybody wants to go and see the technology in action and speak to any of our salespeople, it's in the other hall. It's about maybe, well, it's a long walk, but it's maybe about 700 meters that way and that way, okay? What MMX does, MMX measures manufacturing excellence. And what I want to do today is sort of make a case for real-time data and how it impacts continuous improvement. We'll go through some ROI, return on investment discussion, and I'll take questions at the end. I'll try to keep this within the allotted time of 40 minutes. So here's what we're going to talk about. We're going to talk about the Modern Machine Shop Survey, data streams required to fuel an IoT implementation, production visibility and situational awareness. We're going to talk about a little bit about IoT and Industry 4.0 and what all the fuss is about. We're going to talk about automated OE tracking as a pragmatic IoT use case. We'll talk roadblocks to adoption, some specific examples with some real numbers, some transformational benefits. There'll be a summary, and I said Q&A at the end. So with that, let's get started. So who here's heard of the Modern Machine Shop Top Shops Survey? Okay, good. So it's put out by, as it's entitled, Modern Machine Shop Top Shops. It's done every year. It's sent to about 20,000 shops. They get about 350 to 500, depending on any year, completed surveys. And they compile all these stats. And 48% of the respondents are job shops, 46% are contract shops, and 6% are captive. So it's a good cross-section of manufacturing. And from the genre perspective, 48% are aerospace suppliers, machinery and equipment manufacturing represents 41%, and other verticals include medical devices, oil and gas, and automotive. So again, a good cross-section of genres of manufacturing and types of shops. I'm not going to go through the whole survey because it's like 50 pages long, but essentially what you need to know is that profit margin on a top shop is 3x of what a normal shop is, or an 80% quartile shop, and top sales per machine are almost 400 grand versus 185 for the other 80%. So you say to yourself, what are these guys doing? Well, their strategic development, sales process, and operational processes are very important to a top shop. And here's some specific examples of what they concentrate on. So they're concentrating on, obviously, continuous improvement. 55% of top shops concentrate on continuous improvement. Benchmarking is important. Value stream mapping is important. Formal training program, lights out manufacturing, and obviously tooling and tombstone. These are all things that are important to a top shop and contribute to the results that I just showed you. This is an example of one of our customers that fell within the top shops survey. Trend line, obviously going the right direction. We decreased their QA setup by 72% and increased the runtime by 45% through the advent of data-driven manufacturing, all fueled by real-time data. As another example, same company, but the trend line, again, in the right direction, almost a 90% improvement in OEE. So this is what top shops are doing to increase their profit margins and their profitability. We'll talk now about the data streams required to fuel an IoT implementation. So this particular graphic here is an example of ISA 95 standards for machine connectivity to ERP. So we have the very lowest level here on the floor. We have the actual equipment that produces whatever product the company makes. Then we have a connection, whether it's MT Connect, OPC. If you were here for Neil's presentation earlier, he went in great detail about MT Connect, and that'll be recorded. So if you missed it, you can see it online. I'm not going to do that today. Then there's an aggregation layer on the database, and then an application layer, and ultimately the business system intelligence in ERP. This, again, is the entire solution stack to ISA 95 standards for machine connectivity, shop floor to top floor. We look at, well, what's driving the need for connectivity. We have a lot of stakeholders, customers, suppliers, shop floor, management, the whole enterprise. Everybody requires this data to fuel, but not just the business process, but ultimately profitability. Some of the drivers include higher customer satisfaction, lower cost, competitive agility. Those are some of the things that are enabled by connecting your shop floor to your top floor. I get asked this question a lot. Okay, we buy a brand new Mazak machine or another manufacturer's machine. It comes with an electronic protocol, and I put that on my floor, and that's great. I can pull that data out. But what about all of the other equipment I have on my factory floor? How do I connect it? And so for legacy equipment, This is an example of what we have, but there's other manufacturers that have this product. Again, not going to go into the details, but basically what this does is it sits in a legacy machine and turns that machine into a web server. And then what we can do is we can take that data into a consumer layer, ours or any other one, to solve a pragmatic business use case and create a compelling return on investment. And then I always get asked, well, what does it look like? So here's just some examples of how you can take the legacy equipment and turn it into a web server and actually pull that data out and use it to affect change. I mean, the average age of these controls has to be at least 20 years, probably 25 years. I know this one, I think all three of these didn't even have an Ethernet port. So without an Ethernet port, we're not pulling out any data. So we need to create a data stream that we can consume. When we look at the confluence of those three data streams to create the business use case, what do they look like? Well, we talked about operator data for a minute. So we have three data streams. We have data from the human capital that operate the equipment. We have data that's contained in our business system, our ERP system, things like scheduling and payroll and financial data. And we have, obviously, the machine data on the factory floor. So in a traditional manufacturing environment, what happens is ERP system creates a work order, and then it gets dispatched to the operational management team, go make this and tell me when you're done. In order for us to have a proper IoT implementation and create that compelling business use case, which I'll get to in a minute, we need to have the confluence of these three data streams together. And so if we don't do that, if we just have operator manual data and we have ERP data, in other words, go make this and tell me when you're done, then we get reactive information and we generate lagging metrics. When we do have the ability to connect all three of these data streams together in real time, and I'll show you examples in a minute of what that looks like, we get proactive alerts. We can actually be proactive about the problem rather than simply reactive. And say, for example, you have a manual data collection system and you're aggregating it, and the report goes out the next day for the previous day. Well, it's a little bit too late, and it's latent and it's prone to inaccuracy. If we can connect all these three of these data streams in real time and fuel it with a dashboard that the operational management team can use, we have a much better chance of generating the business outcome that I'll talk about. So when we talk about business system integration, we have to send the data from ERP to the shop floor, from the shop floor to ERP, and that does things like drive inventory and procurement directly. So we're not actually having to key in how many parts were made or how many, what's the raw material requirements for the work orders tomorrow. We'll know all of this based on what we've actually produced, fueling the data back or feeding the data back into ERP. Obviously, job schedules are important. Job progress is important. A lot of customers that have an ERP system with a bunch of manual work orders, somebody calls in and says, where's my particular batch of parts at this time? And somebody will run around the shop and try to figure out where the work in progress is. Is it op 10, op 20, op 50? If we have it in real time, we can just answer that from one dashboard. We don't even have to go to the factory floor to answer the question. And then talked about minimized work in progress. And obviously, if we have automatic data, we're getting accurate data. We can make accurate decisions. Obviously, the best decisions are made with real-time data. When we look at how data-driven manufacturing comes alive for a minute, well, we talked about the connectivity from the shop floor to the top floor. We talked about work order scheduling results directly to and from ERP. If we want to get elegant and take this to the next level, we can take work in progress raw material and high-value tooling tracking, so we know where in the shop all those parts are, whether they're batches of parts or whether they're high-value tooling, fixturing, that kind of stuff. When we do that, we're trying to drive cost and manufacturing process. We're trying to improve our manufacturing process. The best manufacturing processes are fed with real-time data. Process improvement, continuous improvement. There's three things in any factory that change. There's the people. People retire or move on, or we hire new people to expand. There's the product. Everybody's looking at taking on new lines of business, penetrating new markets. And then there's the equipment. So people are constantly about a 5% a year refresh rate of equipment. So like anytime any one of those three variables change, the outcome is uncertain if we're not managing it in real time, because we can't proactively deal with it. We have to react to it when we see things go offside. When we have a factory of the future of data-driven manufacturing with those three data sets, then we can do things like horizontal and vertical integration. And what I mean by horizontal integration is the entire operational management team has one version of the truth and one situational awareness tool to concentrate their efforts on. So there's no objective opinion or subjective opinion. It's all objective data, and it's right in front of everybody for them to see and to use. And we talk about vertical integration, we're talking about extending the access outside our four walls to our trusted suppliers for things like surface treatment or heat treating or something like that. And we can give a heads up to our trusted supplier base, which actually shortens our delivery times and reduces our cost. So what does production visibility and situational awareness look like in the IoT era? Well, this is an example of, on a factory floor, these are and-on screens, and most of our customers will put them out in various locations throughout the factory. And what they'll do is they'll sequester the equipment in that particular area and only have that data displayed. So the operators that are concentrating on that particular part of the manufacturing process don't care about something that's happening on the opposite side of the factory per se. They care about what they can impact right here. So this is an example of one of our customers on an FMS cell, and it defines how manufacturers can generate more revenue and margin. It also captures the production data in real time and displays it so we can look at how our actions are affecting the productivity of the enterprise. And we increase the operational awareness of how downtime affects productivity and what's important and what's not. It's been our experience that if you don't run a report, don't actually use the data, you'll generate a 6 to 10% productivity improvement just by giving the operator the ability to see how they impact their process and how their process is moving forward. This is an example of one of our customers with a Gemba board that's fed directly with real-time data. So the Gemba boards, Gemba's Japanese for factory floor, or go to the Gemba, is part of very much an intrinsic part of lean manufacturing. When we have this ability to populate these Gemba boards with real-time data and things change, we can actually get rid of the paper and just do it all electronically. So rather than have the reports from the previous day printed out and that's today's Gemba board, we can actually have that Gemba board refreshed based on everything that's happening on the factory in real time. We make much more impactful and much more important decisions quicker with the ability to see things in real time. Common objective data right across the entire factory is another benefit, and I guess I told you 6 to 10% just by giving more of the shop floor operational awareness to the operational management team that concentrates on pushing the work through the factory. This is an example of one of our customers who has, this is almost a cockpit for manufacturing, so the operational, in this case, the director of ops sits in this area, the whole operational management team sits here, and they have everything going on in the factory in real time at their fingertips. And so when something happens on that machine there, and it's there in red for a while, they can actually then walk to that particular machine, and they know a bunch of information. They know who's on it, they know what work order, they know how many parts are made, they know a whole bunch of information before they actually go there to investigate the problem. Again, situational awareness, this is just an example of situational awareness in the IoT era. This is one example, this might be another example, this could be another example, and this is another example. So there are lots of ways to slice and dice situational awareness, and many people in the factory will have different reasons for looking at different data. Obviously quality people, operations people, scheduling people, management. I want to talk a little bit now about IoT, and Industry 4.0 and sort of what's all the fuss about. I want to try and bring these three concepts into one common thread called data-driven manufacturing. So in this particular case, this is a stat that I like. If I picked up the newspaper or online or in print and read it every week, I would first of all, I'd find a different number up here, so many trillions of dollars, and I would find a different company that actually attributed this stat was attributed to, and I would find a different quote here. But I like this one the best because it talks about global GDP, and it talks about 2/3 of global GDP will be impacted by IoT in the near future. And in some cases, the immediate future, but in the near future for sure. And this one was attributed to Accenture and Cisco. Essentially, it says that this type of technology harnessed in manufacturing will generate somewhere between $6 and $19 trillion of accretive GDP output. We talk about Industry 4.0 for a minute. I'm not going to go through this, but I wasn't around for the first two industrial revolutions, but I kind of was born around this one. And you know, where we are right now is we're at the convergence of IoT, Industry 4.0, and IoT. So where cyber physical systems are important. If you heard Neil's presentation earlier, he talked about security as being a paramount concern on the factory floor. That's where we are right now as far as Industry 4.0 is concerned. When you look at IoT, this is just a graphic that we use to kind of explain IoT in a kind of a simplistic way. And this is, again, only one business use case. There are hundreds of business use cases. If you look at the data stream from the factory equipment itself, we have MT Connect, FANUC Focus, OPC, or other protocols. We talked earlier about a hardware adapter for legacy equipment. That's essentially the producer layer. We obviously have a bunch of valuable data contained in our ERP system. And then we have more valuable data that we can collect from the operator, and the combination of all three of these streams of data ends up in a database. Ultimately, it generates reports that the operational management team can use to manage the enterprise, and it creates, all these data streams create a compelling situational awareness tool in the form of a dashboard. We looked at where we are in terms of the connected manufacturing revolution. We're probably at this inflection point right here, where we have a technological shift where the internet's been around for a long time. Internet security applied to manufacturing is a relatively new concept. If you heard Neil talk about the Cisco switch, that's an important development because it allows the data, where the data is produced on the factory floor, to be now brought into the fold of what IT manages in terms of what their responsibilities are. So it brings internet security essentially to the edge, which is something that's been lacking for a long time. And that's why we're at this connected manufacturing model, what we call a technological shift right now, at 2017 and beyond. So I want to we talked about IoT, we talked about IoT, and we've talked about Industry 4.0. I want you to consider these three concepts kind of melded into one idea called data-driven manufacturing. So in 1999, MIT created the term IoT, or Internet of Things. Around 2010, the German government created the Industry 4.0. This stat here, IoT, I tried to find a defined attribution between Cisco and GE, and both of them said they created the term, whatever. Well, what we see is a convergence of these three ideas. One of the things that I get asked a lot by senior executives is, how do I monetize? And everybody tells me I have to do IoT or Industry 4.0. How do I monetize the strategy? And so I'm going to go through some real numbers and a business use case we call data-driven manufacturing as one example, not the only example, but one example of how we can monetize the idea of these three, or the promise of these three ideas. So when we talk about the convergence of these three ideas, we're talking about, as a business use case for data-driven manufacturing, we're talking about consolidated reporting, we're talking about big data and analytics, we're talking about corporate dashboards, but all of it doesn't exist without real-time data. Real-time data from the human capital, real-time data from the machine, and real-time data to and from ERP. Without the real-time data piece, none of this happens, none of it. I'll also now talk about a little bit of reality and myth when we take the concept of data-driven manufacturing and apply it to manufacturing. And I'll start with the myths first. So the first myth is it's a theoretical construct with no practical application. The second myth is it's unquantifiable capital expenditure with no defined payback. The third myth is it's a highly technical deployment strategy where the path is unknown and the way forward is unknown. And the fourth one, and the one that I like the best, is it's not a magic bullet for every single problem that manufacturers face today, right? It's just not. Doing this is not going to solve every single problem that manufacturers face. There are a number of them, but let's talk about the reality of data-driven manufacturing. Well, it's both transformative and disruptive. It's transformative in the ability to give real-time data to the operational management team, and it's disruptive because it'll change the culture of the organization, but both for the better. There is a known quantifiable payback with examples and case studies, whether it's our case studies or any other vendor, competitor of ours. There's lots of case studies to understand the why, and I'll get to why the why is important in a minute. It's definitely proven to be a major benefit in eradicating productivity gaps. Our average internal return rate on this type of implementation of IoT or Industry 4.0 is about a 300% internal return rate. What that means is that if you spend $1 with us at the first day of your fiscal year, we would give that money back to you in 4 months, and then 4 months later we give it back to you again, and 4 months later we give it back to you again. So you would get a 3x return on investment for effort expended over the course of one fiscal year, and then more thereafter. It's also available today. So this isn't, again, a theoretical construct. We've done this 150 times with many companies, multiple plants, thousands of machines. So let's look at some of the benefits to explore here. So obviously critical business challenges here are trying to reduce our business costs. Everybody wants to do more with the same level of effort, harness their people and their equipment better. We want productivity and asset utilization maximization, 100%. We obviously want accurate data. We don't make accurate decisions if we don't have accurate data. We want to integrate with our business system, and I'll talk a little bit more about this in a minute, but we want to fuel our continuous improvement programs like Kaizen events and Hoshin Kanri and Deming cycles with real-time data. We get much better results when we do that, and I'll explain that in a minute. So who here has heard the term OEE or calculates OEE, whether it's real-time or manual? Okay, well, OEE stands for overall equipment effectiveness, and it's probably, arguably, one of the most important metrics in manufacturing today. And essentially what it is, it's world-class OEE is 85%, which is 95% in each of the categories of performance, quality, and availability, multiplied by each other. To give a little more detail, availability is runtime divided by total time, which includes downtime. Quality is good parts divided by total parts, which include rejects. Both of those metrics will never be more than 100%. And the performance one, the last one, is the theoretical part-to-part time versus the actual part-to-part time. And this is the only metric that can be above 100%. If it is above 100%, you need to raise the bar. You need to move the product standard up so that you can actually measure again. So things have changed, like equipment that you make the part on, or the tooling that you're using, or the fixturing that you're using, or the coolant, or anything, any extraneous input to the actual manufacturing process that improves the time should then reduce the standard, and then we rinse and repeat. So our whole goal is to try and reduce that manufacturing part-to-part time as low as possible while still making a quality product. And it's really become the gold standard for measuring manufacturing excellence. So what drives the desire for OEE from our customers' vantage point? Well, first off, we're replacing subjective latent data collection with objective real-time data. We're shining a light on dark production assets, or basically lighting up the entire factory. So where there was no visibility, or the visibility required you to walk around the factory floor, we can actually now see it from one common dashboard. We'll talk about this in a minute, but take your lean manufacturing initiatives to the next level. And the last one is reveal the hidden factory. When we start with our customers, I always ask the question, or ask our sales guys to ask the question, what do you think your efficiency is? And the average answer I get is about 65%. The real answer, having done this 150 times, is about 35%. So there's a perception-reality disconnect between how efficient companies actually think they're producing their product versus what the numbers say, right? So when we say reveal the hidden factory, if we take a customer from 35% to 70%, that's obviously 100% capacity utilization increase. And if you have the ability to sell that product and you sell it for a profit, all your input costs, like save and accept material, are already covered. So it's essentially like finding another factory, or a quarter of a factory, half a factory, whatever your numbers are, of additional capacity. I want to talk a little bit about roadblocks and what to be on the lookout for. This is important because when you go down this path, you're going to hit some resistance. Some of that resistance revolves culture management, change management. I mean, let's face it, we don't like to change. We don't like to embrace new technology. We like the same old, same old. So we'll talk a little bit about that. This graphic on the left is how we used to go to market. So we used to spend an inordinate amount of time on the how. We would talk about the hardware that we use, and the software, and the database, and all the important stuff from a technological perspective to actually to be able to deploy this technology effectively. We'd spend a little bit less time on the what, we'd spend a little bit less time on the when, but then we spend very little time on the why. And ultimately, the why is the business use case. It's the numbers that back up the reason why you go down this path. And so what we did about 2.5 years ago was we said, we're going to flip this entire idea on its head. We're going to talk about the why first. And if we can't come to some common ground with the customer about the why, in other words, work the numbers, understand the business challenges, and actually put a business use case in front of the customer that actually we can tangibly measure results against, then we're never going to get to talk about the how, because the how is completely irrelevant, because the project will never get funded. If you go to management with the how, but don't understand the why, the first question your manager is going to ask you, or your president, whoever, CFO, whoever funds the project, they're going to ask you, what's the business use case? What's my return on investment? And if we can't articulate this properly and effectively, the project never gets funded and the project never gets off the ground. I don't know about you, but when I go buy a new car, what's the salesman want to do first? He wants to envision me, he wants to put me in the driver's seat, and he wants to envision me driving down the highway, if it's a convertible with the top down, so that I get integrated with that car, and I want to drive that car. Well, that's exactly what we try to do when we talk to customers about adopting this technology. We want them to envision what this looks like 3 months out, 6 months out, 9 months out, so that we have common ground and measurable deliverables that we can actually vet and have some common ground to agree on. Another issue to consider, again, why focus on the business case? Competitive advantage. Competitive advantage is a big one. Change management and culture of the company is a big one. This tends to slow down the adoption of this technology. And then tyranny of the immediate takes over and we're too busy to worry about it because we've already got 5 full-time jobs and it looks like you're going to add a 6th one to my already busy day. I want to talk a little bit about fear, uncertainty, and doubt. So when we talk about fear, we're talking fear of failure, fear of data and system security. We're talking about fear of the unknown and fear of change. We're talking about uncertainty. We're talking uncertainty of the path forward and what the quantifiable, actual, tangible results will be post-implementation. And we talk about the doubt. We're talking about the promised business outcome. And again, the required culture change to guarantee the success. These are all common fear, uncertainty, and doubts that we see with our customer base when we first start talking about an implementation. So you need to be on the lookout for these because you need to have answers for these. Because various people in your organization are going to ask you questions and you need to have an answer for this in terms of, how are we going to change the culture of the company? If we talk to the operator and we say, look, we're putting this in because we want to monitor your efficiency, they're going to think it's Big Brother. In which case, you're not going to get operator buy-in, and they're going to resist every step of the way. But if we tell the operator, look, this is an inclusive tool. We're all going to use this data. We're all going to learn together. We're all going to get better together. You'll have a much better chance of having operator buy-in. And if that data stream is one of the 3 that we need, we absolutely need operator buy-in as one example. When we look at all the doubts we talked about, all the uncertainties we talked about, and all the fears we talked about, we end up with what I call the analysis paralysis problem, because we add all these up, we get inaction, endless delay, paralysis, and most importantly, if you understand that and agree with my business use case, and I said on average we generate 300% internal return rate, we're talking about a tremendous amount of lost opportunity cost for every 3 months, 6 months, 9 months, 12 months that we don't actually embrace this technology and get on with implementing it. I want to give you an example of return on investment with real numbers. Factory on the left is a typical customer or typical factory that we see, sub 40% OEE, and the lost time are usually in one of these 5 buckets, right? Maintenance, setup, downtime, small stop, speed loss, and the productive time is this last bucket here. When we talk about the factory on the right, post-implementation, world-class OEE, you notice that we've got our utilization way up and we've got all these little buckets here well under control and well understood. So this is a pre-implementation average customer, this is post-implementation world-class. Some companies will only ever hit this bar or only hit that bar. The higher we go up here, to get from this level to this level is the easiest part. To get from 63% to 72% is infinitely more complicated and difficult because it requires more things that you have to change within the factory itself. Every 1% above 60% is probably twice as hard as the percent before. When we look at the value proposition, where does this percentage increase come from? Well, it comes from no one bucket accounts for a big number. You look 2 to 5% for real-time numbers, including alerts. In other words, we're alerting people about substandard performance, productivity issues, reducing downtime, minimizing rejects. All of these little things add up to 10 to 50%. But no one bucket accounts or no one problem accounts for the majority of it. It's all small little things that we couldn't see before because we weren't looking for them. We look at an example here of a small and medium manufacturer with 30 machines running 5 days a week, 16 hours a day with an $85 an hour loaded labor cost. For the purposes of costing the project, we're going to talk about 30 machines with 15 of them requiring one of those little hardware devices that we have to plug in because it's a legacy piece of equipment. We're going to talk about 3 minutes of downtime increase per machine per hour and 2 minutes because we have increased visibility. Remember I said those Gemba boards and the end-on screens on the factory floor. All of this aggregates to an 8% increase in OEE. We look at the results here. The project cost was, we saved 40 hours, all shifts, all machines, 1.33 hours per machine per shift. We spent $150,000 approximately. What we generated in the first 12 months, $850,000 of additional profitability. Our internal return rate was greater than 400%. Our payback was less than 3 months, but over 3 years, we generated $2.5 million of additional profitability by increasing the OEE number 8%. That would, if you use the number of about $300,000 a machine, it would be just sub 10 million bucks of gross revenue. Some additional transformational benefits, as we talked about, impactful continuous improvement. So we connect all our machines, we monitor and assess our productivity in real time, we identify bottlenecks and constraints, we analyze downtime, and we discover the hidden factor, we rinse and repeat. What does that do on the upside? Well, obviously it increases our profitability, improves our on-time delivery, improves quality, improves uptime. What does it reduce? Well, it reduces our bottlenecks, reduces our setup time. All these things go in the right direction. All the accretive things go up, all the negative things go down. Obviously reduce costs and waste. We look at a traditional and you can insert whatever program you want here. I just picked Kaizen because it's pretty well understood. We take a traditional 7-step Kaizen procedure with no real-time data. This is the iterative process we go through every single time. So we collect some manual data, we determine a root cause because we aggregate that and analyze that manual data, and then we come up with a hypothesis after we have come up with a countermeasure and implemented it, and we collect some more data and we actually see whether that was accretive, neutral, or negative, and then if it was accretive, we implement a solution and we change our standard work and then we iterate this process again. But every single time we do this, we're wasting time collecting manual data, and that's probably arguably the most time spent in a Kaizen event, is collecting the data in the beginning, aggregating it, coming up with the idea, collecting data at the end to validate it. If we look at a revised 5-step Kaizen procedure with real-time data, well, we shift our emphasis to the two things that are really important in a Kaizen event. We're actually going to develop and implement a countermeasure, we're going to hypothesize a solution, and we're going to implement. We're going to spend no time collecting data here, and we're going to spend no time collecting data there. We're just going to run reports. We're going to let the system itself, the data-driven manufacturing system, collect all this data, and all we're doing is running reports. So when we do that, we save a tremendous amount of time. We could probably do 2 or 2.5 Kaizen events under this methodology than we could under that methodology, because we're not spending our time with, standing over the operator with a stopwatch and collecting data. So again, we're spending time here, which is where the important part of a Kaizen event should be spent. Customer success stories, there's a whole bunch of this on our website. I want to leave a few minutes for questions here, but you can see these numbers, they're all systemic. The actual different genres of manufacturing and aerospace or large equipment manufacturing, it really doesn't matter. We have customers that make coffee pods, those 33 million of those little Keurig K-cups a month, and this technology applies to them, and they don't cut a chip. So it doesn't really matter what you make. Again, here's some other examples. These are all gleaned from case studies that we have, and they're all on our website. Whoops. They're all on our website. I'm not going to go through these in any great detail. If you want the copies of the case studies, just let me know. I'm happy to send them to you. So in summary, it's being done today. Why wait? I just gave you a very compelling business use case. 4-month payback. The path is known. The why should always be the first discussion. Internet security should be part of the equation. Metrics require real data to function. Real-time data is the most accurate. And with that, I think I'm done. I'll take some questions. I have about 6 minutes, I think, for questions. Does anybody have any questions that they would like to ask? He has a microphone.
Right. Out of the 150 instances where you had a chance to implement this, what would be the ranges of revenues for these companies where you had the most success?
We've done everything from small, medium enterprise, 5 million, sub 5 million revenue, up to Fortune 50 companies with billions of dollars of revenue. And the problems are the same regardless of where you go. Obviously, if you have 5 or 6 machines, it's a little easier to walk the factory floor than if you have 3 factories in different locations. So the payback has been relatively the same in terms of, it's on average 300% internal return rate or 4-month payback, regardless of genre of manufacturing, regardless of size of company in terms of gross revenue.
Right, thank you.
Does anybody else have questions for Dave?
Okay, well, thanks very much for your time.